Question number 11. Let x represent the number on the face that lands up when a fair six-sided number cube is tossed. Die. The expected value of x is 3.5, and the standard deviation of x is approximately 1.708. Two fair six-sided number cubes will be tossed, and the numbers appearing on the faces that landed up will be added. So we're looking for sum. Which of the following values is closest to the standard deviation of the resulting sum? So I want you to think about what happens when you add standard deviations. What happens when you add standard deviations? Now you can't straight add standard deviations, right? You have two standard deviations here. And what's going to happen is we know that, well, it's two die. So the probability of, or the expected values for both die and the expected standard deviations are both going to be the same number. So let's think about this. We have two die. We'll represent x represent the number on a face that lands up when a fair six-sided number cube is tossed. So we're tossing two die, two cubes. So what we want to do is we want to combine those, right? We're going to add. So the mean of adding those two is absolutely going to be 3.5 plus 3.5. So in other words, the average sum is going to be 7. The standard deviation, though, it's not quite the same, right? We have to think about, we don't add standard deviations, we add the variances. Variances are standard deviation squares. So we have to square the individual standard deviations. 1.708. And I want you to think about this as a Pythagorean theorem type question, right? A squared plus b squared equals c squared. So the standard deviation of those two number cubes being added is really the square root of the sum of those squared numbers. See what you get when you plug that in. All right, work it out, see what you get. Here is the solution. And I'll get rid of the extra right in there. You do get about 2.415. We do not add standard deviations, we add their variances, which is squared standard deviations. And just for good measure, you can watch here my calculator. If you want to type what I have in, basically what I did I did a distribution 1 out of 6, 1 through 6, and I did 1/6. And then for these probabilities here, this was, the probability of getting a 2 was 1 out of 36. Probability of getting a sum of 3 was 2 out of 36. And then I went 3 out of 36, 4 out of 36, 5 out of 36, 6 out of 36. And then the most common one was a sum of 7, and then it counted down. So 5 out of 36, 4, 3, 2, and 1. So those are those probabilities. Now watch, I'll get the mean and standard deviation for both of those so you can check those. So if I were to do one variable stats using L1 with L2 as my frequency list, you can see the mean of those is 3.5 and the standard deviation is 1.707 right there, or 1.708. All right, makes sense. Now let's look at the one variable stats. This time I'm going to use L3, that's my sum one, with my frequency list as L4. Look at your average is 7, right? Because 3.5 plus 3.5 is 7, but look at your standard deviation. It is 2.415. So we don't add the 1.7s together, we square those, we add them together, then we take the square root. Fun stuff. Next question will be number 12.